Alright, so evidently my run caps on this top half, these were both shot. One of those ones is shot. I haven't replaced that one. I disconnected the bottom whole thing. This is all off. It's just using the single top module, which is capable of outputting over 50,000 volts DC. I swapped out the two bad caps here. They went from 20 UF down to being about 16, 17 NF. So they weren't passing any current, letting any noise through. The thing is currently powered on right now, and it's drawing very little power. So that's 2 amps at 12 volts, 12.5 volts. And the voltage that's sitting on Sprink up here, let's see if we can get up there without getting shocked. Right, 30,000 volts. And that's on the Sprinky up here, Sprinky Dink. Alright. And I had to turn the variac way down because full power and shock the crap out of me through the wood. Let's see. So there's the input on the variac. Amps, volts, something like 40 volts in. And the amps is not really registering on there. But what else is kind of interesting here is the spectrum change. When it was common negatives, the only part of the spectrum that was being tweaked was down here on this side, that first brick. But now that it's got the positive and negative set up, and it's pushing 30,000 volts, we're getting this flare that reaches out all the way across up here to 700 megahertz or so. It's lifted all of that up. And we verify that by turning it off. There, it's starting to fade away. Most of the stuff to the right of this peak right there, this is usually not there. It's usually flat. There's an occasional spike or 3 out here, but this is usually flat all the way up into there. Relative negative had this side just getting all hashed up, but when this thing's on, it hashes all the way up there, right? And that's only at 30,000 volts. It's not full power. You turn it back on so you can see the hash build. So that's interesting. And then the other thing that is interesting is the EMF meter. Set that to magnetic. And note this. It's on magnetic. The other with the common negative had the magnetic field steady. This one's churning a magnetic field up, down, up, down. And the field doesn't reach very far. This is like 3-4 feet. You turn around and face the other direction, you lose half of it. And it's not because I'm in the way, it's just because you're farther away from the field. If I move off to the right, it stays the same as if it's right in front of me. But even just in front of me, you can see it's churning. So that's magnetic, and then the electric field is pretty much the same as it was before, except that, you know, I can still interrupt the magnetic field. Sideways, come back around, and set this down. If I'm not touching the box, it fluctuates better. And then I can shade it from in front. And I can be a ways away in front or even just kind of off to the side and it shades it. When you get up to a certain point though, and it pushes it right back up. those caps are starting to fail again. Anyway, that's interesting. Let's see if we can turn it up just a hair. I don't want to get shocked though, so let's see. Activate the variac from this side. Just kicked into funky sounds. Wait. Man, I wish I had a little more space. Alright. So now you can hear it, actually. And I don't want to get too close now because then I can't zoom in. So now you see we're off the top of this. It's a 40,000 volt meter. Shorting and sputtering over here. Magnetic field. Larger rate of change the closer to the actual gap you are. I mean, this is really not pulling a lot of power, man. This is electric field. Either reading the electric field on me or it's the actual electric field. Well, it must be picking it up on me. Huh. Trippy. And then the input power right now is only like another amp, so it's 3 amps at 12 volts. Running the Sprinky dink. So, and then look at the hash over here. It looks like it's adjusted and increased a bit. It's spread. At the lower setting, the hash only came to about the middle. But now it's blowing all the way out up here. Up here is like 800 megahertz. Turn it off so you can see. Ready? Off. Huh. Definitely has some kind of a magnetic inertia there, huh? Maybe it's a electrostatic equivalent of the Aspden effect, where you know, once you set a permanent magnet rotor in motion and then stop it, as long as you start it back up within a certain period of time, 30 seconds or a minute after you stop it, it doesn't have the same inrush current because the fields are still in motion or in some kind of an inertial state. Looks like it's mostly cleared out. Let's flip it back on just to see. This is now set up the correct way with the positive electrodes on top and the negative pair on bottom. And mostly facing north like indicated. So it'll be interesting to see if this has any kind of positive effect or a negative effect or no effect.